This is part 2 of section 5.1, proving that an equation is not an identity. An identity has to be true in every single case. So a single counterexample is all that is needed to prove an identity false. So on these example problems, we are asked to prove that the equation is not an identity by finding a value of x for which the two sides have different values. One thing I want to stress to you is that there may be values of x for which this thing is true. For example, if we use the angle 0 or 2 pi, depending on how you want to think of it, then tangent of that point is 0. Secant at 2 pi is 1. 1 minus 1 is 0. So we do have a value for x that will work here. But it's not an identity because it doesn't work for everything. So basically what I'm saying is if the first angle you try gives you something that is true, pick another angle and make it work. There are likely to be several that will work. So for example here, it was true here with 1 and 0. But what's happening over here, this is how I'm thinking through this. I'm subtracting 1. So as long as this isn't equal to 1, I'm not going to get a 0 here. Tangent is still 0 at pi, but cosine is -1, so secant is also -1. So if our x value is pi, then tangent of pi equal to secant of pi minus 1. This would say 0 is equal to -1 minus 1, which is -2, and that is not true. One counterexample is all it takes. You could have also chosen pi over 4. And in that case, tangent of pi over 4 is 1. Secant of pi over 4 is the square root of 2 minus 1, and that's not equal either. You'll likely have a bunch of options, but the first one you try may end up being true. Just don't give up on the whole thing. Okay, so let's try sine squared x is equal to 1 minus cosine x squared. Pi is easy to deal with. These are going to be zeros and ones, so why not try it? Let's try x equal to pi. Well, sine of pi is 0, so that would be 0 squared equal to 1 minus cosine of pi is -1, so that becomes 1 plus 1 squared. So this would require that 0 is equal to 4, which is not true. So we have a single counterexample. Okay, again, stressing there may be values of x that this is true for, but we're not worried about that. We wanted to show we're hoping an identity is true for everything. And if we could pick a single value that makes it not true, it is not an identity. Okay? So where else do we go? We're going to be asked in this chapter a lot to verify trigonometric identities. And it is a different process from solving an equation. We're trying to show that it is true for all values and not trying to find at least one value for which the equation is true. This means that we are not going to be allowed to do the same thing to both sides of an equation. That really only works if we know we have something that is equal. Okay? What we're going to end up doing is transforming one side to the other most of the time. Okay? There's no one path that works for every identity, but there are some strategies that will help you. And I've put a note in here. You're going to find yourself going in directions that lead nowhere. That's part of the process. Okay? Don't give up on the whole chapter because you run into problems with one of them. And you're going to get better and better at this as you go along. It does not mean that you cannot do this math. this stuff does build, yes, but just because you have trouble with number 2 doesn't mean you're going to have trouble doing problem number 3. So don't give up on everything, okay? So here are some tips. The first 2 tips are almost always useful, and that is to start with a more complicated side of the identity, and we're going to simplify that until it becomes the other side, okay? We also want to stay focused on the final expression, okay? If your final expression has secant in there, then you probably want to try to find a secant when you are simplifying. So just stay focused on that goal. It will help you pick a good path, okay? Now the final 3 tips are sometimes useful. They're not appropriate for every problem. You may want to rewrite everything in terms of sine and cosine. It often works. It often gets really ugly, and there are usually easier ways to get it done, but it is an option. Occasionally, you're going to have an identity where both sides are kind of complicated. So it won't make as much sense to start with a more complicated side and try to convert it to the simple side. We may want to simplify both sides and try to end up at the same place. Okay? And use conjugates. If we have something like 1 plus or minus sine, plus or minus cosine, if we multiply by the conjugate, then we get a difference of squares. We end up with squares and ones, which means that we can use our Pythagorean identities to simplify things. Okay? So these usually help. These sometimes help. And let's work a problem. Okay? Verify each identity. So we're going to start with our more complicated side and try to transform it into our simpler side. So here we have cosine x, cotangent x, plus sine x equals cosecant x. Okay? The left-hand side is definitely my more complicated side. So what I'm going to do is I'm going to start right here, and as a shorthand, you can just say left-hand side equals, so you don't have to recopy that. And here I have a cosecant, which is a sine. It's 1 over sine. Here I have a sine, and with cotangent has a sine in it as well. So I'm going to transform this into sines and cosines. So what I have here is cosine x times cotangent is cosine x over sine x plus sine x. Okay, so multiplying here, I have cosine squared x over sine x. And here I have just sine. Well, I want to be able to combine these, so I'm going to get a common denominator. So if I write this as something over sine x, then this is sine squared of x. Now combine across the top. And the numerator is one of our Pythagorean identities. It is equal to 1. So I have 1 over sine x. And by definition, 1 over sine x is cosecant x, which is equal to the right-hand side. So we didn't do the same thing to both sides. I started with the left-hand side, used a bunch of simplification techniques, and found out that I ended up with the right-hand side. So this is always true. It is an identity.